So sometimes when we don't have the right conditions for estimating a parameter and we want to find a confidence interval anyway, we can use a technique that we might call bootstrapping or bootstrap resampling. And to first start talking about this topic, let's actually discuss what bootstrap resampling is. And then in a later video, we'll talk about how to obtain a confidence interval from a bootstrap sample. So the idea is, if we have a small sample, and small, again, in our case, could mean less than 30. It could really mean extremely small. It could be something as small as 4 or 5 data points. But as long as they've been obtained using a proper sampling technique, as we discussed in Chapter 1, right? Representative, not biased, uses random selection, then we're free to use this small data set to create a bootstrap sample. So what a bootstrap sample is a sample of the same size. So if we have n, like 10 or 15, if we use the same size to obtain a new sample, where the first one is obtained, where it's obtained from the original sample by random selection with replacement. So to illustrate that, so we have some x1 star, some x2 star, and each of these is obtained at random from the original sample until we have n of them again. Okay, and so this is our bootstrap sample. We'll illustrate briefly, not exactly at random, but we're going to simulate the randomness using a very small sample. So, as an example, suppose we have the set 1, 5, 9, 13. Okay, so there's 4 data points, very small, right? And how many bootstrap samples we want, we will denote by capital B. So let's say we want to obtain 3 bootstrap samples. So what we'll do is, and we could sort them if we want to. We don't necessarily have to. But for each of these samples, we're going to randomly select from this set, from the 4 data values that we have here, right? Maybe the first time we get 5, right? And then we randomly select again and we get 1, and we randomly select again and we get 1, we randomly select and we get 9, okay? So with replacement, of course, means that we could get the same data value twice or 3 times or however many times, as long as it's random, right? Again, we're simulating here, but the idea is each time we're randomly selecting. So that's the first bootstrap sample, right? So each data value, right, is generated by selecting at random. And then we start over, right? So the next bootstrap sample, we again are taking just from this pot of 4 values. So maybe it's, we get 9, 13, 5, and 5. And then again, 1, 13, 5, 9. Okay. We can arrange it if we want. We can sort it, right? So 1, 1, oops. Let me space it out a little bit more. So 1, 1, 5, 9. And 5, 5, 9, 13. And 1, 5, 9, 13. It's very possible that we get the same original sample again. But each time that we construct a new bootstrap sample, we are essentially artificially generating a larger data set, because if we started out with 4 data values, now we've added on 3 times 4, and in general, what we're actually doing when we're taking bootstrap resampling is we're taking some small sample size and we're actually increasing it to b plus 1 times n. And so you may wonder, how do we efficiently do this, or what's the best thing to do here? We want to make b as large as computationally reasonable. For this reason, we typically will use a computer program. If you are more programming inclined or have some experience, there's some pseudocode for a function in the textbook that illustrates how we would create this repetition of for however many Bootstrap samples we have, right? Maybe 3, maybe 10, maybe 1,000, right? We're going to repeat this process of randomly selecting the first, second, third, and fourth. So we stop each time at the sample size that we started with, right? So our original sample size is n, or in this case 4. So we repeat this random selection 4 times, stop, and move to the next line. Randomly select with replacement each time, right? And then you stop. So we actually have 2 repetition structures here. So the repetition structures that we have in the pseudocode are what we call while loops and for loops. So they just determine the conditions for which we're going to repeat the random selection in each Bootstrap sample, and then how many times we're going to process and obtain a new Bootstrap sample. So in other words, we're going to loop a loop that goes 4 operations and then one that goes b operations. And in the end, we get our new collection of Bootstrap samples. So this is artificially creating from the original sample a much larger data set, which represents the same population. And so what we'll cover in the next video is how to actually construct a confidence interval from this.